I've got the NVIDIA 5080 Founder Edition that NVIDIA was kind enough to send a little ahead of time for me to take a look. It's in the box. It's in the box. It's not actually in there. The specs on paper show this card is a major upgrade over the 4080. It's got the little adapter cable in here too and some documentation. But the early benchmark leaks show the sky is falling. Right, I mean, 8% performance uplift in Blender? That's, oh no, that's basically accurate for Blender. But way wrong for games! How about that? The 5090 Raster non-ray trace performance uplift was an impressive 30%, upwards of 50% in some cases in our testing, especially around 4K. And that's even before we get to ray tracing, which is also a substantial uplift in all the AI features. Can we expect similar major raster performance uplift with the 5080 down the stack in gaming? No. But it's better than 8%. We got more CUDA cores, a higher clock, 16 gigs of GDDR7, and a higher board TDP of 360 watts. All that is significantly increased over the 4080. MSRP for this FE card is at $999, which is a better deal. But these are going to go quick, and the AIB partner cards are likely to be much more. If you compare the specs side by side, the 5080 does look pretty good, though. But to get you an answer succinctly, I've got to bring you along on an adventure of new technologies and fun stuff, because it's actually a little more complicated than that, because we got to talk about 1080p, 1440p, and 4K. You're buying this card for 4K, right? First, this card comes in this advanced yet eco-friendly feeling cardboard. Like, this is not a trick, it is actually cardboard. It's fun. It's almost exactly identical packaging to the 5090. If you're going for the 5090 unboxing, and you want it to be $1,000 plus less expensive, I can assure you it is exactly the same unboxing experience. It's just the delightful new cardboard smell. You're not going to want to throw this away. You just want to hang on to it. I don't know, it's just cardboard. It's pretty similar. Look, you got 3-pin adapter cables, so 3 8-pin PCIe power connectors to NVIDIA's new, more reliable 16 power connector. That's actually a 12 power pins plus 4 sense pins. It's a new connector design, new strain relief. Really nice, as it's very bendy and much more efficient. At least for the Founders Edition from NVIDIA, this power cord is going to deliver up to 360 watts to the 5080. The 5090's 600 watts, so it needs more power connectors. So here's something that's innovative. The noise and thermals from this card are even better than the 5090, owing to the fact that this card is only using 56% of the power of the 5090. I was a bit surprised by this because, well, at half power, this card is generally more than half better than the 5090. But maybe I'm getting a little ahead of myself. This card is also PCIe Gen 5, so if you use this card on a riser or an extension cable, keep that in mind. As almost all riser cables, extension cables, fancy pants side window extensions for your PCIe cards out there today have poor compatibility with PCIe Gen 5, because Gen 5 is very, very fast signaling rate. And you can't always set it to Gen 4 and get it to work. In my testing, PCIe Gen 4 versus Gen 5 didn't actually make much of a difference in performance, at least when we're talking about gaming workloads, 1 to 3% in gaming scenarios. This is maybe something we could do another video on later. There are some different scenarios, especially with AI, where you need to load things in and out of the VRAM really quickly, where PCIe Gen 4 to Gen 5 can make a bigger difference. Think about those Threadripper systems. You know what's coming on this channel. But I'm going to revisit CUDA performance on native Linux, because that was not actually ready at the time of this review. More on that later. Although we can run CUDA on Windows, we're going to run Ollama for the AI section. So use the chapter markers if you're interested in that. There's actually 4 or 5 major things we need to talk about with the 5080. First, in case you didn't know, this generation is all about AI. Everything's about AI these days, isn't it? AI for gamers we'll talk about first, but don't worry, I've also got Ollama and AI productivity benchmarks as well. Not just Procyon, actually using it with DeepSpeak, because hey, this version of DLSS, there's simply no avoiding talking about DLSS and all the new stuff in DLSS 4 and everything that brings to the table. A lot of new technologies, a lot of upgrades to the old technologies. And before you hyper-focus on the rasterization performance only, the ray tracing is more and a bigger part of newer titles. I mean, look at Cyberpunk 2077. That's not even a new game anymore, but game designers are starting to lean pretty heavily into technologies for AI upscaling, for frame generation, and technology that is a force multiplier for ray tracing and ray tracing type technologies in general. Critics might say that the big studios are issuing game optimization. Just let the AI deal with giving gamers a good gaming experience. Maybe not. Maybe we're starting to see more games that really just have ray tracing requirements baked in. I mean, Indiana Jones, the new Indiana Jones game, Spider-Man 2, Avatar, Frontiers of Pandora, I mean, they list ray tracing as like a minimum spec in the game. And having played Indiana Jones, it is actually a lot of fun with ray tracing and everything else. So NVIDIA has some impressive marketing material that you should check out apart from this video for DLSS frame generation, DLSS ray reconstruction, DLSS 4 multi-frame generation, which is multi-frame generations at 5000 series card feature only, and other AI features that are rolled up in the software. NVIDIA Broadcast, which is also a lot of fun to play with, and there's a new version of that coming out, which will probably be another video. Neural rendering is a kind of texture compression, means that NVIDIA can deliver really detailed immersive game models, but without using as much VRAM. And then DLSS 4 multi-frame generation, which is the controversial thing this generation. This is NVIDIA's answer, multi-frame generation, to give you 240 hertz on a 4K monitor, like this one. This is awesome. The new driver that's launching with the new DLSS cards also has a new upscaling model. There are specific videos on this new upscaling model, but this is also a model that is available on 4000 series cards as well. From my own personal experience with this technology, I was really impressed on the limited games that I tried it on, especially doing the side-by-side with DLSS 3. This is pretty good. As long as the game will deliver playable FPS, the frame generation technology, closing the gap from 60 to 240 FPS was reasonable in my experience. The technology actually seems to work pretty well. Aside from some minor nits that I would pick with frame generation, multi-frame generation, in my opinion, the DLSS 4 technology, the whole suite, the whole enchilada, is dramatically improved over DLSS 3, more than I thought would have been possible. And I'm a bit of a holdout for this tech because, I just wanted to run fast natively. We'll have a few more side-by-side comparisons when we get into our game benchmarks, but at launch, NVIDIA promises 75 games and apps can benefit from multi-frame generation. I only actually had a chance to test a few games for multi-frame generation, and I really looked for artifacts and weirdness, but generally what I saw was impressive, like I say. And yes, don't worry, we're going to talk about Raster Performance Uplift versus our Asus TUF Gaming 4080. Don't worry. Here's the new enhanced DLSS 4 ray reconstruction for you to take a look at. Definitely check out NVIDIA's videos on the new DLSS 4 ray reconstruction and all the new DLSS 4 features. There's a link below. Check out the Level 1 forums for an even less YouTube compressed version of this. But yeah, side by side. I'll let you be the judge, but the DLSS ray reconstruction here is minimally a marked improvement over what you could get in DLSS 3. I mean, that I think is pretty plainly obvious. But will gamers accept it? Will they use it for the performance boost aspects of it? I mean, I had fun with it in Cyberpunk, at least. Okay, let's talk AI. Real AI now, not the AI that they're stuffing into games. The fake frames. Do fake frames win games? So the AI tops figure is double that of the 4080 series. 1500 tops. That's because the newer Blackwell architecture will let you slice the available bits for numbers into smaller slices, a smaller int format for AI workloads. We see that in Procyon benchmarks. Like, that's the big Procyon. It's like, oh, the huge generational uplift. It's not it. I mean, we're running 4-bit on both, but to be clear, yeah, it's not exactly an apples to apples comparison. And it's 16 gigs of VRAM. I mean, sure, 32 gigs of VRAM on the 5090 is insanely way better, but you can get a lot done with the 16 gigs on the 5080, to be sure. And you see that in the benchmarks. Now, the version of Procyon that we're using here is also a special version of Procyon to be able to properly take advantage of the new stuff in Blackwell to be able to deal with the new integer types that will let you run the AI models with, less precision, which is awesome. And I would expect that the scores here that you see to be improved even quickly after launch. They're not I mean, Procyon is actually a good benchmark, as is MLPerf, which is available to run all this kind of stuff. Forget those benchmarks. DeepSeek R1 at home, that's no problem whatsoever on the 5080, the 14 billion parameter version. In fact, here's the video of me doing just that with Ollama on Windows. And this isn't even as good as it's going to get. Let me tell you, CUDA on native Linux is going to be even a little bit better than this, but this isn't bad. So what I'd like to do is ask our DeepSeek model to write an efficient program to search for perfect numbers. That's really pretty much all the prompt is. But look at this. Look at all the output that is coming from this. In this case, like I say, I'm using the DeepSeek R1 14 billion parameter model with Ollama. This is a model downloaded from Ollama, and you can see that it's using about 12.7, 12.8 gigs of VRAM. The evaluation of my question takes a while because it's deceptively complicated, which is why it makes an interesting prompt. And the output is coming at a blistering 62 tokens per second, we can see in our Ollama verbose output. I also want to show you this insane thing from DeepSeek. Check this out. This is a developer working on WebAssembly and being able to run SIMD accelerated WebAssembly in the browser. So the developer was using DeepSeek and just says, hey, I would like to use SIMD to speed up GGML in llama.c. The prompt for this really wasn't too crazy. And it did it. The green text here, this is coming from DeepSeek. Like my prompt, where a relatively short prompt generated a lot of code, it generated the code here. This shakes me to my bones. This is nuts if you comprehend what's going on here. DeepSeek came up with this, and this is reasonably good. Well, except for this one part, which is a little redundant, which then you also ask DeepSeek about, and it says, oh yeah, this is a little redundant. We don't need this part here, which is funny because, you know, it's like, this is literally the proverb. We are living in interesting times. This is interesting times. So for gamers, let's call them gamers with a capital G, I suppose. Less serious gamers. I suppose the story here, I mean, the thinking is, will this be enough of an uplift over the 4080 or the 4080 Super? And I think that gamer with a capital G is not likely the type of gamer to lean into multi-frame generation and some of the other features. I mean, maybe the new transformer model, maybe DLSS super resolution available via the driver updates, but you get those for the 4000 series cards too, just not multi-frame generation. For the gamer with a capital G, they're going to care pretty much only, I think, about our benchmarking, where we're showing that 12.5 to 15% performance uplift generationally, mainly for 1440p and 4K results, with 1080p being variably worse generationally in terms of uplift. I mean, are you really buying a 5080 to do 1080p gaming? For that capital G gamer, the only real viable option this generation is the 5090, with its much higher generational uplift, and its dramatically much higher price. As we like to say in this channel, lies, damned lies, and benchmarks. Shadow of the Tomb Raider rasterization, 135 versus 132 FPS on our 4080. Oh, it's the end of the world. The sky is falling. There is no generational performance uplift here. No, not actually. This is why you got to pay attention. This is the highest preset, and at first these results do look a little disappointing at 4K. Okay, maybe it's a little better at 1440p and 1080p, but this is also the highest preset. Check out the high preset. 171 versus 197 FPS. This is an older title. It's useful because it reaches very far back in time. It does give you an idea of generational uplift when basically in any scenario on any CPU, you're not really super CPU bottlenecked. 323 to 295 at 1440p, 356 versus 342 at 1080p. It's really interesting. I'm pointing it out. I don't want to wax poetic for a long time because these reviews are, this review's already run long. This is also an example of, like, a lot of the time the benchmarking and stuff that we do doesn't necessarily make it into a video unless it's interesting, or unless it's a representative sample of stuff that we're doing. And Shadow of the Tomb Raider is still a pretty representative title, especially of older games, but I really thought it was interesting that for the highest preset, there was basically no performance difference. But for the high preset, there was. So you're still getting something out of the 5080. This is more game than 5080, I think. Don't blame the GPU, blame the game architecture. Cyberpunk Phantom Liberty, and this is a non-default setting here. At this point, Cyberpunk by default is using ray tracing and upscaling technologies, ray tracing secondarily, but you have to go into a custom preset to disable any of the upscaling features altogether. And 75 versus 47 FPS is a significant update. This is like what we saw with the 5090. The 5090, depending on which area of the game that you were playing in, if you're playing in the Phantom Liberty, Dogtown area of the game, even in some of the more populous areas, it was a significant performance uplift compared to the built-in benchmarks or compared to other play areas in the game. So there's a little bit of variability there. And also pretty reasonable uplift from 1440p. But 1080p, you start to notice like, this car is really not doing much for you in terms of uplift at 1080p. Your biggest gains are at higher resolutions. That makes sense. Borderlands 3, positively ancient title at this point, and there really isn't a lot of difference at any resolution between 4K and 1080p. 4K has the biggest difference, 97 to 118, but again, is this generational uplift or is this minor improvement? I mean, would we call this like 4080 to 4080 Ti levels of improvement? I mean, it's not a lot. So let's take a look at ray tracing on, DLSS performance, and frame gen on. Hogwarts Legacy. My goodness. You also get a nice breakdown here of how things are performing between the 5080 and the 5090. The 5090 is in a whole other class, but the 5080 is holding its own when we are leveraging all of the technologies. I also spent a fair bit of time actually playing Star Wars Outlaws, running around. I got into a weird state where I actually lost my save because I think something went wrong because I was signed in too many places, but that's neither here nor there. Spent a lot of time in Star Wars, and Star Wars actually was a lot of fun as long as the base frame rate before I was using multi-frame generation was playable. And at 243 FPS on the 5090, we're working with about 1/4 of that at 60 FPS, and it was perfectly fine. It was a little bit more of a rough experience on the 5080 at the same graphical fidelity settings. I really wanted to dial that down just a little bit. Even though it was 161 FPS, it didn't feel quite as good as it did on the 5090. All in all, this is a strong showing for the 5080, though maybe not if you are on a 4080, unless you're going to lean into multi-frame generation technologies or new technologies that are 5000 series exclusive. If you're on a 3080 Ti, yeah, this might be a worthwhile upgrade, especially if you can get one for $1,000. Like if you were, goodness. As for our canned benchmarks, Geekbench 6, OpenCL, I think the results pretty well speak for themselves. We got a nice linear gradient here, going all the way down to our comparison Asus TUF RTX 4080. In case you were wondering, is the 5080 better than the 4090? And the answer is no. 3D Mark Port Royal, again, 4090 is better than the 5080, but these are pretty respectable scores, with the 5090 being in a league of its own. The Puget Creator Suite, it stacks up pretty similar to what we saw with the 5090. The encoder improvements and the overall platform improvements, pretty solid here. It might be nice to have more VRAM. It's a bit of a push with Photoshop. In one of the Photoshop benchmarks, the 5080 is actually better than the 4090. For other gamers, lowercase g. As I said in my 5090 review, NVIDIA has bet big here on the AI features and the new DLSS features and multi-frame generation. Now, I've been a big skeptic on DLSS technologies in the past, and I suspect that many gamers are actually going to embrace these technologies, the lowercase g gamers. Unless I misunderstood, NVIDIA said that 80% of the people that are using the driver, the people they have telemetry from, are using some DLSS technologies. And so certainly multi-frame gen is going to factor into that moving forward. I mean, it's not a thing yet. DLSS 4, other features, well, yeah, I mean, maybe. So what percentage breakdown of gamers are going to be happy with multi-frame generation and all of the other features or upscaling? All GeForce RTX users are going to have available to them the experience for the new transformer-based DLSS stuff and DLSS ray reconstruction, super resolution, DLAA in over 50 games and apps when it launches. And time will tell if this cohort of gamers also adopts multi-frame generation. I think the lowercase gamers are going to use pretty much all the technologies, maybe multi-frame generation, but probably also. And that's a 5000 series thing. I suspect the uptick will be more than the capital G gamers expect, but probably not as much as NVIDIA would like among competitive gamers. I mean, if you're using multi-frame gen on something like Indiana Jones, okay, sure, but competitive gaming, well, NVIDIA promises Reflex 2 is going to help with that, but our exploration of that is going to have to wait for a future video. And I like the MSRP of this $1,000. Gamers with the capital G will probably say that this is a price reduction over the 4080 to make it, make up for the relatively weak generational uplift for pure raster performance. But it doesn't seem like many partner cards are actually going to be priced close to $1,000. So being able to actually acquire a 5080 for $1,000 might not be a reasonable expectation, because, well, or you may be waiting a few months, or we may see what the market happens, and tariffs are a thing maybe. Really scary times. Here we are at the beginning of 2025. Moving on from the 5080, it sure is going to be interesting to see how the rest of the stack of 5000 series GPUs are going to line up. Now that's about all we've got for launch day for the 5080, but be sure to stay tuned for our Linux video looking at the 5080 and the 5090 in a Linux context, natively, CUDA, AI performance, everything like that. I think also, because the driver is going to change so much, so many games that I can't test today are going to unlock on launch day, that I think that I'll want to do a fast follow on some of the other games that launch. So if there's a game that you really like or that you think will benefit from some of the AI or upscaling or other technologies like that, let me know. And also probably check out the forum, because YouTube compression is weird sometimes in terms of like the side-by-side and the side-by-side image. Like we did a nice thread on the 5090 on the forum. Check that out for the 5080 as well for the side-by-side, because I think the images there were higher quality. But I digress. It's late, I'm tired. This review's been a long time coming, a lot of work, a lot of headache. I'm gonna go to the forum now and hang out. Let me know if I missed anything or if there's anything in particular you want to see, because oh boy, RTX 5000 in the house. Very exciting. All right, I'm signing out and I'll see you there.